Right. So a perfect square trinomial. Here's what a perfect square trinomial is. It's a trinomial that's made up of two factors that are exactly the same. Perfect square trinomial. I'll move it. It's the result of squaring a binomial. Okay? It's the result of squaring a binomial. I'll show you what I mean in just a minute.
That means.
So the result of squaring a binomial. So if I take a plus b and square it, I get a perfect square trinomial. And the perfect square trinomial is a squared plus twice the product of ab plus b squared. As a matter of fact, we talked about this before break. This is a long time ago because we had break in there, right? But there's a trick for squaring a binomial. Here's the trick. See if you remember this. We square the first term. What's the first term of this binomial?
X.
X. So I square x. We square the last term and stick it on the end. I think Miss Kiersey had said hook it on the end. So, well, 16, yes. And then here's the tricky part. You ready?
2AB.
We take the 2ab part means take x times 4 and then double it.
So
What's
4x?
not quite. What's x times 4? 4x. Now double that. 8x. 8x. So what we're going to be doing today, guys, is going this direction. I will give you the perfect square trinomial, and you're going to factor it as a binomial squared. So every one of these perfect square trinomials will look like this, with either a plus or minus sign in between the two terms. So, guys, if you can take the square roots of all these numbers, this lesson will be easy. What's the square root of 16?
4.
Look at where the 4 is here. What's the square root of x squared?
X.
Look where the x is here. And a lot of students will ask me, well, what happened to the 8? Well, the 8 is what you get if you double the product of these two. Okay? Now, the other shortcut we're going to learn today is called the difference of squares. And a difference of squares is when we take two perfect squares being subtracted. That's kind of weird, the grammar. Two perfect squares being subtracted can be factored as a plus b and a minus b. In other words, we take the square root of each term and write it as a sum. Sum means adding the two. And then we write it as a difference. Difference means subtracting the two, right? So a difference of squares, here's how you recognize it. It's a difference. You guys see how this is a difference? X squared minus 36. It's a difference of two perfect squares. Let me let you finish writing this down. Look at it one more time. So we're talking about perfect square trinomials. That's a perfect square trinomial.
I'll just start doing
Joe. Wait, if I say squaring, are you like square root?
Yes. So I am square rooting each of these terms. As a matter of fact,
So if you can't really square root,
you can. The square root, guys, what's the square root of x to the second again? Just x, yeah. So I can square root that. And what's the square root of 36? 6.
Oh.
So we'll learn two different factoring techniques. One for a perfect square trinomial, and then one for a difference of squares. So before I show you guys the shortcut here, let's talk about how we would factor something like this before. This is before break. Notice, what's the number in front of the squared term here?
K squared.
1.
1. So can we factor it with just our x? Yes. And it would look like this. We're looking for factors of 64 that add to equal 16. And you're going to notice something, a pattern here. These two numbers on these types of problems that we're looking at here will be the same. Okay, two numbers that multiply to equal 64 and add to equal 16. What are they?
30.
What multiplies to equal 64 but adds to equal 16? It's 8. Yeah.
21.
And so, what does that mean in terms of my factors? What are my two factors written in parentheses?
You're gonna look 6 plus 6 and X
Yes.
minus 6.
But it's a K. It's a K.
Oh,
And it's
A minus square.
plus
Sorry.
because there are only pluses in this. Now, instead of writing two things twice, we have a shorthand way of representing K plus 8 times K plus 8.
It's K squared.
It's K plus 8 quantity squared. Now, here's the shortcut. You guys ready for this? This will make your classwork super easy. If you recognize that this is a perfect square trinomial, here's how we recognize it. Look at the first term. Is it a perfect square?
Yeah.
Last term is a perfect square. Now, is this middle term double the square root of the last term? Square root of the last term would be 8. Is the middle term double 8? Yes. So this is a perfect square. So all you have to do, guys, is take the square root of each
That
one.
was all.
So
There, let's flip that.
take the square root of each one. What's the square root of k squared? Of k squared is k. 64 is 8. Square root of 64 is 8. So guys, all you have to do is look at the problem here. Let's try it on this one. Is this a perfect square trinomial? What do you think, Titan? Is this a perfect square trinomial? Is it a trinomial? Yes, it has 3 terms, right? What makes it a perfect square is this a perfect square?
Yeah.
Is this a perfect square?
Yeah.
Is this double the square root of this?
Yes.
Square root of this is
No, 8.
4.
Unless it's a positive 8.
It doesn't have to be. Here's how we handle it. That's a good point. This is a perfect square trinomial. The only way it differs from this is it has a minus sign in the middle. So here's how we handle this. The square root of w squared is
W.
w. We match the sign, okay? And the square root of 16 is,
8.
that's half of 16.
4.
4.
Wait.
And that's it, guys.
I
That's
take-
the whole problem.
That's the whole problem.
That's
Are
not
you sure?
fair. You said
That's
I said 7. You said
Then wait, why was that one so much more than the next one?
I was showing you how we did this before.
Oh, okay.
But,
So,
guys, all you have to do is recognize that it's a perfect square trinomial. First of all, trinomial is 3 terms. Perfect square is, is this a perfect square?
yes, it is.
How do we know it's a perfect square?
because it has an X and
It has an x squared in the front and a,
you can square the 36.
yep, and if I double the square root of 36, do I get the middle term? Yes.
And
So,
when you get X minus 6 in parentheses with the 2,
yes, this is x minus 6 squared, okay?
even more sleep. And what did you Yeah.
Go ahead.
The
Yes, I asked you to change it, so go ahead and change it.
Alright, so
Okay, guys, the last one here. I'm going to go over it. Okay, the last one. I asked you to change this one because there's some on the classwork and then some on your next skill test, skill 15, where you have to find the GCF first. Do you remember that, where the GCF is?
Yes,
greatest common factor.
Yes. So, can anybody tell me, looking at this, what the GCF might be?
9.
9.
It would be 12 if 12 went into 27. It could be 9 if 9 went into 12, but it doesn't.
6. 3.
3 is the biggest number that goes into each of these, so Monty is right. So here's what we do. Did you? Okay, we divide each of those by 3. Okay? And we also write the 3 as a factor. Okay? So write the 3 out in front of the parentheses. And then What's 12 divided by 3 equal?
Wait, we can factor it like this too?
It's 4.
Well, it's not 2, it's a two-stepper, okay? So you have to do this first, but there's more to it.
So you're saying that we can factor it like this too, if we want to?
You can factor it like this if it's a perfect square trinomial.
So basically what you're saying is like if it equals a number that you can divide it by and factor it like the same way.
If it's a perfect square, in other words, that number times itself is that number,
Okay.
both in the end and in the beginning, and if you double the square root of this number, it equals the middle.
Oh, okay.
So you have to check that too. Okay, just let me finish this talk here.
It's 12 divided by 3.
Yes, 36 divided by 3 is 12x, and 27 divided by 3 is 9. So now, okay, so right here, do you guys recognize this one? Is it a perfect square trinomial?
Yeah.
Yeah, it's got 3 terms. Is the first term a perfect square?
Yeah.
Last term.
No.
If you take 2x times 3, that's 6x, and double it, you get the middle term.
Yes.
Yes.
Then it would be
It's 3 times, go ahead. 2x?
times 2x plus 3.
Yes, squared.
Yeah.
And that's it.
I'm scared.
Good.
And then you got this one back.
That's it for that one.
I'm talking about the one there.
Okay, the ones on the back are even easier.
Oh, sure.
Yes.
Uh-huh.
I'm almost done.
I do. Oh, is this
Here. David.
Yes.
Which one? You what's on top of mine?
Yes.
David.
So wait, Mr. Brown. First one, 81 is 9 times. So then would it be x plus 9 and then x?
Yes. That's it.
Oh my gosh.
Anybody else need more time on this?
No.
You got it?
I do know you need it.
You good?
John, I do know you need top. New shoes.
All right, guys. I need it quiet. Hanger.
The hanger is upstairs. Wait, I think everyone
Okay, this is going to go quickly, guys, so I need you to be watching. Okay, guys, I need you to be watching here. Flip it over, backside. This is going to go quickly. All right. That's it, back. All right. This is what we call a difference of squares. Do you guys see that this is a difference? What makes that a difference?
It's got an arrow point.
It's got an arrow pointing at the minus. Do you see how there's 2 perfect squares? Okay, guys, I need it quiet. Oh, wait. Here, let's wait. I can explain.
No, I was just.
I know. We got it figured out.
Okay.
Arrows?
All right. This is a difference of 2 perfect squares. It's got a minus sign and it's got 2 perfect squares. Here's how we factor it. What's the square root of x squared?
X.
What's the square root of 81?
9.
7.
And so we write this as x plus 9 and x minus 9, and we are done. So a lot of students ask, what happened to the middle term? Well,
There's not a term.
there isn't, because if I multiplied 9 times x, I would get positive 9x. And x times negative 9 is negative 9x. If you add those two together, what happens to the middle term? It's not split. It becomes extinct. It's gone.
It
9x
becomes big.
plus negative 9x is 0x.
Okay, yeah.
Let me just do a couple more here. What about this one?
I have no problem with it.
Plus.
That one's 3x.
Okay.
Plus 5.
What's the square root of 9x squared?
3.
3x. What's the square root of 25? So we have 3x plus 5, 3x minus 5, and we're done. Okay, as long as it's a difference of squares. Out of these last two, which one of these is a difference of squares? One of them is and one of them is not.
49C to the second.
98 is there.
This is not a perfect square. So this is a difference of squares. How would you factor this one? What's the square root of 49C squared? 7C. What's the square root of 1?
1.
Good. Some students have trouble with that. They don't see that, but
There's no minus or plus.
there is a plus on one and a minus on the other. Now, this one I asked you to change. Scribble it out, write 2y squared minus 98 if you didn't already.
I did.
It is not a difference of squares as it is. But we can make it into a difference of squares.
You use decimals, right?
No. We can make it a difference of squares, though. Every time you factor a quadratic polynomial, you should always look for a GCF first. Is there a GCF?
Yes,
This problem.
98.
98's not the GCF.
100.
2 is the GCF because 2 goes in each of these. They're both even numbers, right? So I can divide each one by 2 and place a 2 out in front like that. Put a 2 out in front, divide each one by 2. 2y squared divided by 2 is y squared. 98 divided by 2 is... Now look at what's left. Is that a difference of squares?
Yes.
Yes.
7.
Square root of 49 is 7. So I would factor this as what times what?
It's y minus 7 to y 2.
Y minus 7 and...
Y minus 2y minus 7.
Y, no. The 2 only gets written down once. We've pulled it out. It's factored out. The factors that are left are y minus 7 and y plus 7.
Alright, how long is this class?
That's
not 36.
Well, if you use the shortcut, it's not long at all.
Which,
What I just demonstrated.
the
This round,
Square root of each
this round.